Alright, so the first thing I want you guys to do, if you look over here on our board, we are going to go over the homework first. So if you can see over here, I want you to pull out your last night's homework, which was only those 6 questions. So pull out that homework, we're going to go through it quickly, and then we're going to move on to the procedures of what we're doing for the lab today. Alright, here we go. Gentlemen, go ahead and have your homework out, please. I want to go through this in, it only takes about 5 minutes or so. So I want to make sure that we get through this in the first 5 minutes. And then I want to start going over the procedures of our lab today and explain how it's going to work when we're doing the lab. Alright, question number 1. We had section 1 assessment last night. You had to do numbers 1, A, B, and C, and numbers 2, A, B, and C. Pretty short. Alright, question number 1 on page 203 goes over. It says, basically, what is it that this chapter is talking about? What's a volcano? Trent.
A volcano is a weak spot in the crust where molten material or magma comes to the surface.
Good. So it's that weak spot in the crust where there's some crack kind of formed, and that molten material, that magma, is able to seep through our crust and make its way up onto our surface. Over there. It's not big. I'll look around, but we have to go in here. All right. So good. So that brings us to our lab today. We are actually going to create a hot spot and that kind of weak spot in some surfaces today, which I have the materials up here. I'll explain how we're going to do it once we get there. All right, number 2 or number 1B. Where are most volcanoes located now? Where are most volcanoes located? Madison, what do you have for 2B? Okay, good. So they're at the different types of plate boundaries. Now, some of you might have stated ring of fire, because that is where the most volcanoes are. But where they actually are occurring are at the plate boundaries. Why do they occur a lot of times at the plate boundaries? Oh, why would a volcano occur at a plate boundary? This is going to 1C. It's answering kind of 1C.
Lava will pour out of the cracks in the ocean, and over time it'll make them.
Okay, so it's going to form through the crack. Adam?
It's why they would occur at plate boundaries, right?
Right.
Okay, well, the plate boundary is like an open crack in the surface, so it's like it's already a place for lava to start coming out, so, well, it's open and, like, it's a weak spot.
Good, good. So it's kind of that weak spot. It's where either plates are converging or they're diverging. They're either coming apart, they're going together, and what's it do? It creates a crack. It creates that crack where 2 parts are meeting together. Think about that. If you had your hands, when you have water, or let's say maybe a handful of sand, when you have a handful of sand in one hand, everything that's sitting there in the cup of your hand is going to sit there after enough has fallen off of the sides. But now when you have 2 handfuls of sand, everything's going to sit in there for the most part, but look right here in between. You kind of have that crack. That's the weak spot. So that's like the 2 plates that are combining together. So there's a little bit of a weak spot where eventually it might stop, but for a while there might be a little bit of sand that falls through the middle of your 2 hands. And that's the same kind of process of a volcano. No, nothing's not falling down, but because it's so light and dense, the magma and the lava, it's coming up through the earth. So once there's that weak spot, kind of maybe a little tiny bit of a crack, if there's enough and it's large enough, that will allow the lava or the molten material to seep through the surface. Good. So that brings us to our lab and number 2A. What is a hot spot? So what's a hot spot? Claire, what's a hot spot?
A hot spot is an area where material deep in the mantle rises and wants to form magma.
Good. So where an area that's deep within the mantle will melt and will eventually form magma. And once it forms magma, they'll find a crack because it's less dense, it's going up, and once it finds that crack, it seeps through our surface and turns into kind of lava. Alright, number 2B. How does a hotspot volcano form? Now, how's a hotspot volcano going to form? Trent, go ahead.
Hotspot volcano forms above a hotspot when magma erupts through the crust and reaches the surface.
Good. So exactly kind of what we're talking about. They all kind of go together a little bit. So once it reaches that surface and the lava is able coming out, then you have an actual hotspot on our surface. And then number 2C. What features form as an oceanic plate moves across a hotspot? What do you have there? Go ahead, Aiden.
Sorry for the interruption. May I speak to Chris for a minute?
Chris,
Thank you.
go ahead.
Okay. An ocean floor can gradually form a series of volcanic mountains.
Good, excellent. So over that, as an oceanic plate moves across a hot spot, it's pushing magma up. What happens when magma and lava reaches our surface? What's it eventually do? What's it eventually do? Good. So eventually it cools off and hardens. And if it's deep within the ocean, over perhaps an oceanic plate, when it's in the ocean, it's going to kind of form a volcanic mountain range that's under the ocean. If it's so large that eventually it could form, new land or an island as it makes land kind of grow. So very good.
Sorry, me again.
Yes.
Claire,
There. Alright, here's what I would like you to do. Here's what I'd like everyone to do. I'm going to ask that everybody goes ahead and clears their desk, and I want to go through. You can put your homework away because I want to get started on this lab. The stapler didn't work, so each person needs two, but they're together, so it's like this one. You want a stapler? Here. No, my stapler works as the printer stapler. So they're all together, so there's 1, 2. Okay. Here we go. What we're going to do today. 6th grade. Thank you. What we're going to do today, I have all the materials up here because we just did 8th grade, because I just had 8th grade in here, I had other materials out for one of their labs. We had completely different, so it's kind of last minute. We got to get these things set up fairly quickly. So in here, what we're going to work on is we are going to create a hotspot volcano. We're going to actually create a hotspot volcano. Now, how this is going to be done today, because I only have one area that works as our hotspot, which is this hot plate actually that we can heat up. So it's actually going to work as our hotspot, but we have 30 students in here, or roughly, 26 students in here. So as we do this, not everybody can go at the same time. I'm going to have us in groups, and I will have us kind of come up as a table, and you'll work on it kind of together as a table. And I'll explain, I'll be up here helping you through. Now the rest of us, while we are working on while one group is working on the lab up here, the rest of us are going to be working on a lab worksheet and a section 1, which is on the volcanoes worksheet, that Adam and Chris are going to pass out in just a moment. So they're going to get it around. So you guys are going to have actual stuff to do that relates to the lab and that relates to section 1 that we just went over yesterday. Now, for how the lab works, what we're going to do up here, you're going to have, and I'm going to allow you guys to set up the materials just as we've done for previous labs. That way I'm not setting it all up for you. You guys are getting in the process. You know, we'll break off into the group. Some people will be filling up water. Some people will be filling up the beakers and whatnot, whatever it is that we're doing. All right, so in here, I have a bag full of wax, and really it's just a bunch of cut up candles. So it's a bunch of different cut up candles, and these candles are going to simulate our hot spot. So you'll have a beaker as a group. The candle will go right in the center of the beaker, just go down at the bottom of the beaker. Once we have the beaker, I have two different types of sand. We're gonna experiment with both. We are then going to cover, this is just black sand, it is sand. We're going to cover the wax of the candle all the way up with sand. You're not going to fill the entire beaker up, but we're just going to fill it up enough to where there's no more wax that is showing through. So it's going to cover the wax. After the wax is covered, we will then fill the beaker up about halfway of water, and I kind of have an actual measurement up here. We'll fill it up about halfway with water, and once it's on top and filled up with water, we will then stick it on our molten material, which is heating up from inside the earth, our simulation of it, which is the hot plate. And as it heats up, who can predict, what do you think is going to happen as the hot plate is heating up the beaker, and there's wax underneath, there's sand on top of it, and there's water above? What do we think? What do we predict might happen? Addison.
The wax is probably going to start melting and then coming up above the sand.
Good. So the wax will actually start melting. It'll start coming up through the sand, because sand is kind of, like our cracks. Obviously the sand isn't one solid thing that's going over. There's all different types of grains. So eventually, when the wax gets hot enough, it's going to get less dense, it's going to rise up. So as it rises up, it's going to make its way through the sand, but then there's water. What happens when the lava, reaches into our atmosphere, into the surface? What happens? It cools off and hardens, right? It cools off and hardens. So we're going to see how that forms. This is going to be like kind of a hot spot over an oceanic plate. So it's going to be kind of as if it were underwater. And it's going to cool off, and then you'll actually see how it hardens. It almost looks like, in this simulation, kind of looks like it could form almost like a coral reef is what it looks like, but that's kind of, describes the volcanic mountain ranges that might occur under the water. Okay? So how this is going to work, because we only have one hot plate, I am going to have you guys working on this worksheet. You have 30 minutes in here. It's working on the lab worksheet as well as section 1. And then when it's your turn, I will call each group up to come and actually perform the lab up here as a group. And we're going to watch as it unfolds. So quietly, I'm going to get this set up. You may start working on your worksheet, and I'll let you know when it's your group, or it's each time to go ahead and come on up here. Six, work quietly, please. That way we can get everyone through today. You might need to use, Johnny, the handheld one that's right next to the mechanical one.